What is vertical motion?
No clue.
It is
What's vertical? Up. Or up and down. And motion is, so we have movement up and down. Okay? So what I want you to picture is you have the ground. That is a terrible color to use. It's very light. Okay? Let's say that is the ground. Okay? Let's say, you don't need to draw this, by the way, unless you want to. I'm just trying to give you an example of what we're doing. Let's say that we have a person. Okay? And that person is holding a ball.
Nice.
Let's say it's a baseball. Whatever. Let's say that they are going to throw it underhand up into the air. Okay? Underhand up into the air. And that ball is going to go up. And then eventually, because of this thing called gravity, it's going to come back down and hit the ground, and it'll probably bounce and such. Right? Okay? I'm sorry, what did you just say? Say that again. That was genius. Say that again.
Looks like a parabola.
That looks like a parabola. You want to know why it looks like a parabola? Because it is a parabola. It is a parabola. So, we know some things about parabolas, yes? Yes?
Yes.
Yes. Okay. What is, if I talk about the vertex, okay? When we talk about the vertex, we are going to be talking, by the way, about some things that, let's see. If I were to do this and make this an x and a y axis, then guess what? My y-axis would represent the height of that ball. Okay, I'm sorry, let me say that again. What axis represents the height? The y-axis. So in other words, if I were to find my vertex, the y value of that vertex would tell me the absolute height that ball would go. Right? That's as high as it's going to go. What do you think the x-axis is? The time. So in other words, the time it takes to reach that height is the x value of the vertex. Okay? Now, you will get some questions that say, hey, when is that ball going to hit the ground? Well, if it's hitting the ground, I'm looking for the time, but what do I know about the height if it's hitting the ground? What's the height of something on the ground? 0. It has no height, right? So I can plug in a y value of 0, and I can find what time it is that it hit the ground. Kind of crazy? So these are we're going to get some scenarios, and we're going to try and put them into this type of a problem, okay? So what I want you to get from this is, when I ask you, when does an object reach its maximum height? What am I looking for? When? I'm looking for the time of the vertex, or in other words, the x value of the vertex. If I'm asking what is the maximum height, I'm looking for the y value of the vertex. If I'm asking when does it hit the ground, I'm looking for what is x when the height is 0. Okay? Now, we will also get into things called initial velocity. What's velocity? Do you know another word for velocity? Speed. Okay. There is a difference in velocity if somebody physically throws something up versus if somebody simply drops something. Because if you drop something, you're not putting force to make it go faster. It's only gravity acting on. Whereas if you toss something up, you can toss something up really fast, or you can just gently toss something. So that velocity at the beginning is going to affect some of these values here. Okay? So, if we look at our notes page, there is a very, 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 very important formula that you need to know. And it's so important, I'm going to highlight it as soon as I can find my highlighter. Here it is. Right here. H of t. What does H stand for? Height. What does T stand for? Time. Where H is the approximate height in feet, T is the time in motion. V is the initial velocity. Now, sometimes you will see the initial velocity written like that. Now, I know that's tiny, right? Make it bigger. Sometimes you will see it V sub 0. It's a subscript of a 0, also known as V naught. And it'll look here, they'll have a little 0 right there. That just means the initial velocity. And the problem will have to give you that, okay? In physics, you'll do stuff to find that, but in our problems, you're going to give that, okay? So, we're going to use this equation to find our information. So, I have an object. It is thrown upward from the ground. So, it's starting at 0, going up, and then it's going to come back down at 48 feet per second. That right there is my velocity, or my V sub 0, whatever you want to call it. We'll just stick with V because that's easier. How do I know it's V? Because velocity always gives you a distance in a given time. It's a speed. Miles per hour is a velocity. Inches per second is a velocity. Meters per second is a velocity. It always has a distance and a time with it. So, what is my vertical motion model going to look like? Well, if I take this equation, I have h of t equals negative 16 t squared plus 48 is my v value, t plus, let's see. Let's go back to the equation. What did it say? H is the height in feet, V is the initial velocity, C is the initial height. What's the initial height? 0. Because it's being thrown upward from the ground, and the ground is a height of 0. So that's my equation that I'm going to be working with. Okay? By the way, where does the negative 16 come from? Somebody's tush, right? It's just some random number. No, it goes back to gravity and some things that some physics people have put together and stuff, but it has to do with gravity there.
How come it isn't 9.8? How come it isn't 9.8?
It changes depending on what unit of measurement you're using, whether you're using feet per second, whether you're using miles per hour. The number can technically change. Okay? All right. So here's my model. My next question, well, look, it's asking me for a vertex and for an x-intercept. Well, vertex I understand, because the vertex, if I go back to my picture, the vertex is going to clearly be helpful, right? So let's find the vertex first. What form is that in? Standard, vertex, standard form. So how do I find the vertex? Negative b over 2a. So that would be negative 48 over 2 times negative 16, which is negative 48 over negative 32, I think. Yes? Okay, so let me do that again. Yes, yes. Negative 48 divided by negative 32, I get 1.5. Okay? Let's go ahead and leave it as a decimal. Because 1.5, you can't see what I'm writing. 1.5 makes more sense if I'm talking about the fact that 1.5 is the time. Makes more sense than 3 over 2, right? So my vertex is 1.5, comma, how do I find the y value of that vertex? Plug it in. So I'm going to plug in 1.5. So negative 16 times 1.5 squared plus 48 times 1.5, and I really don't need to put the plus 0, right? So this is what I've got if you need to see that. Negative 16 and then 1.5 squared plus 48 times 1.5, and I get 36. So my vertex is at 1.5, comma, 36. X-intercept. How do I find the x-intercept? Well, the x-intercepts are what you get when you either factor, use completing the square, or use the quadratic formula. If I'm looking at this, and let me get rid of the 0, I have negative 16t squared plus 48t. What I want to do is when I find the x-intercept, let me go back to my picture. The x-intercept is when what? When y is equal to 0. So I'm going to take my equation, and instead of setting it equal to something that's y, I'm going to set it equal to 0. Which means I may have to factor, I may have to snowflake, I may have to use quadratic formula depending on the circumstance. In this case, I think I can take out a t, and I think I can take out something else. What else can I take out? Can I take out an 8? Does it matter if I take out a positive 8 or a negative 8? No. Shouldn't really matter. So let's see. That gives me negative. I'm going to take out a negative 8 just because I really can't stand it when I have a negative a value. So that gives me 2t plus, nope, not plus, what? Minus what? 6. I didn't take a big enough number out. That's okay, it'll all work out. So, when I solve this part right here, I set negative 8t equal to 0. What do I get? Divide by negative 8. I get t equals 0. Yeah? When I set this equal to 0, 2t minus 6 equals 0. I'm going to add 6. And yes, I could have taken out a bigger number there, but it'll end up working out for me. I get 2t equals 6, so when I divide by 2, then what? T equals 3. Now, both of these were answers when my height, or my y value, was 0. So in other words, I have the point 0, 0, and the point 3, 0. What does that mean? Well, that means if I look back at this picture here, this one's a little bit different because the ball did not start at the ground, did it? So we have a circumstance where if this is my y-axis and this is my x-axis, at 0, 0 is where that ball starts. It goes up, and then it comes back down, and it hits again at 3, 0. So in other words, there are 2 times where my ball has a height of 0. At the very beginning when it hasn't been thrown yet, and then 3 seconds after it's been thrown, it's back at the ground. Does that make sense? What is my vertex? 1.5 comma 36. So in 1.5 seconds is when it reaches its height, its maximum height. So let's see what questions we've got about this one right here. When does the object reach its maximum height? When it asks a question, when, what's it asking for? A time. So in other words, I need the time at that maximum height, which is what? 1.5 what? Seconds. How do I know it's seconds? because if you look up here, we're dealing with feet and with seconds. Okay, so please label them. What is the maximum height? In other words, how high does it end up going? 36 what? Feet. And when does the object return to the ground? Again, it's when, which means they're asking for a time. 3 seconds. So that ball is in the air for 3 seconds before it hits the ground again. So? Those are all my questions. So if I'm given another scenario, if I can identify the vertex and any x-intercepts, I can answer all that stuff about what's going on with that situation. Okay? So this one, an object is shot upward from ground level, which means my initial height is 0 again, at 112 feet per second. So if I use that equation from up above, h of t is equal to negative 16 t squared plus what? 112t. And then plus 0, because my initial height is 0. By the way, if I were to look at this guy, this one does not have an initial height of 0, does he? So what if I said that this guy was 4 feet tall? Or he was like 6 feet tall. But when he released the ball, it was 4 feet up in the air. So in other words, he's throwing it, but when he lets go of the ball is 4 feet up. Instead of being ground level. Because really, can you throw something from ground level? Not really. If it's 4 feet, then guess what that does? It just makes that a 4. Okay, so that's just the starting height, wherever the ball is being released. All right, so here we go. We've got that. Let's start off by finding our vertex. How do I do that again? Negative b over 2a. That would be negative 112 over 2 times negative 16, which is negative 112 over negative 32. Is 3.5. So my vertex is 3.5 comma something. Now think about this for a minute. The last problem, when did the object hit its maximum height? After 1.5 seconds. This one, at 3.5 seconds, it's going up for 3.5 full seconds before it hits the top. So do you think that it might go a little higher than the other one? Why do you think that is? What would cause it to take more time to get to that maximum? The initial velocity. This one, the initial velocity was 48 feet per second. This one's 112. That's more than double the initial velocity. So it's being shot up a lot harder. So it's going to spend more time in the air. All right? So let's go ahead and plug our 3.5 in. So negative 16 times 3.5 squared plus 112 times 3.5. And I get 196. Whew! When does the object reach its maximum height? 3.5 seconds. What is its maximum height? 196 what? And then the last thing is I want to know, when does it return to the ground? How do I find that? Well, I find my x-intercepts. That's where I do the factoring part. So let's see, negative 16 t squared plus 112t equals 0. I don't need to put the plus 0, right? I can take out a t. Is there anything else I can take out? Is 112 divisible by 16? It is. I'm going to take out a negative 16. That's going to leave me with t minus 7. What do I get from here? Negative 16t equals 0. Divide by negative 16. and t equals 0. So in other words, 0, 0 is my initial x-intercept, right? That should be expected. That's the starting one. What do I get from here? I get t equals 7. So in other words, I have 7, comma 0 as my x-intercept. What does that tell me about when the object returns to the ground? 7 seconds. So that's actually a long time in the air if you think about that. Throwing something up and it's 1, 1,000, 2, 1,000, 3, 1,000, 4. That went high. Yeah? Yes?
So, you know how, okay, the vertex is always going to be the midpoint, like the middle, right, of the x-intercept?
Explain that a little bit more. Ask that a little bit more.
So, like, can you try finding the x-intercept first, and then once you get 7, that's how you know what your x value is for your vertex?
Okay, so her question is, if I find out that this is 7, can I just cut it in half to find that value instead of going through this? Because that's been the case here, and it's been the case here. 3 seconds cut in half is that 1.5. My answer to that is sometimes, because when you have situations like this, let me step back for a minute. Yes, when you have intercepts, your vertex is always going to be halfway between them. So yes. However, when you have a situation like this, do you see that by the time it hits the ground, you may have an answer of like -1, which doesn't really make sense for time because that really isn't part of the equation. But it would be halfway between this intercept and that intercept. Okay? And we're going to talk more about those intercepts when we get back from Thanksgiving break. But yes, as long as you have 0, 0, and 7, 0, that is a way to get your vertex. Other questions there? Okay. Let me see what we've got here. All right. Let's change it up. You jump off of a 15-foot high diving board. I personally wouldn't do that, but somebody did. With an initial upward velocity of 3 feet per second. So we're no longer throwing something in the air. We're jumping. Now, a diver is going to start at a certain height. If we think about it, here's the diving board. Here's your diver. This diving board is 15 feet high. Yeah? And let's say they, I'm kind of drawing this strange, but they're going to jump off, and then they're eventually going to hit, let's say this is the water. Right? So hitting the water would be your height of 0. Yes? Okay. Now, we have to think of our equation from the other side. H of t is equal to -16t squared plus, what's my initial velocity? 3t plus my initial height. What's my initial height? 15, because we're not starting at the ground anymore, are we? We're starting 15 feet up in the air already. So I have to put a plus 15 there. Now, this one does not have the blank for the vertex. It does not have the blank for the intercepts. It's just asking me, how long will it take me to hit the water? Do you see that? So do I need to know the vertex? No. Is your method about finding the intercept and then going halfway to the vertex, is that going to be helpful for me? No, because I have one of those situations where the other 0 is actually going to be over here. It's going to be kind of funky. So what I want to do is I just want to find out, when is my height 0? Okay. Now, I could factor this, possibly, but I don't know if it's going to give me a nice number. So truthfully, the easiest way to just get going and get to my answer is to use quadratic formula. The reason why I say it's the easiest is because if this can't be factored, it still has an answer. It's just not a nice number that's your answer. This will get me to the answer every single time. Factoring will only work sometimes. I don't want to try a method and then have to redo it again. So I'm just going to go straight here. What is my A value? Negative 16. What is my B value? 3. What is my C value? 15. So let's see. Negative 3 plus or minus the square root of 3 squared minus 4 times negative 16 times 15 all over 2 times negative 16. All right, negative 3 I'm good with. Bottom's going to be negative 32. And let's see what we get under our radical. 3 squared minus 4 times negative 16 times 15, 969. What is the square root of 969? It's ugly, isn't it? 31.12. So watch what I'm going to do. I'm going to break this up. No, I'm not going to do a tree. This is the same as saying negative 3 plus the square root of 969 divided by negative 32 and negative 3 minus the square root of 969 over negative 32, right? That's what this plus or minus thing means. It means one of them's a plus and one of them's a minus. I'm splitting it up because I'm going to put that whole thing in my calculator and get an answer. You ready? Rather than rounding off, because one thing you'll know if you're dealing with decimals and stuff, the sooner you round off in the problem, the less accurate your answer is. You don't want to round off if you can avoid it. So let's see. I'm going to do negative 3 plus the square root of 969. I'm going to hit enter, get my ugly number, and then hit divided by, nope, did that wrong, hit clear, didn't want to hit clear. Negative 3 plus square root of 969. Now I'm going to hit divided by negative 32, and that gets me negative 0. We'll say 9. Okay. Why did I get a negative number? Isn't this an x-intercept? Guess which one I just found? I just found this one. The other one should be a positive number, and that's the one I'm looking for. Make sense? So now I'm going to come back and do negative 3 minus the square root of 969. Hit enter. Divided by negative 32. And I get 1.06. I'm going to call that 1.1. So how long will it take me to hit the water? Well, it's not going to take me negative 0.9 seconds. That doesn't make sense. It's going to take me 1.1 seconds to hit the water. Does that make sense? Does it make sense why you throw this one away? Because that's giving me, technically a parabola does have this side, but since that's time, you can't really have a negative time. That just doesn't make sense. Okay? All right. I think I'm going to leave it there for today and give you your homework. Your homework's only 4 questions. Okay? And maybe if we need some more help tomorrow, I'll go over number 4 with you guys. Okay? Happy studying.